we have the following supply and demand problem. Quantity demanded is given by this linear function, A minus BP plus E times I sub 0, where I sub 0 is aggregate consumer income. Okay. And notice we assume in this problem you're given A is positive, B is positive, and E is negative. So the fact that E is negative means what kind of good is this? It means income has what kind of a effect on quantity demanded? Yeah, it's an inferior good because income has a negative effect on quantity demanded. As income goes up, quantity demand goes down. So this is an inferior good in this case. Okay. The supply function is just dP, where D is a positive parameter. Okay. And in equilibrium, of course, QD equals QS. Okay. To solve for the equilibrium price, just set QD equal to QS. And doing so, we get adding BP to both sides, we get and now factoring out the P on this right-hand side, we get then dividing both sides by B plus D, we get the equilibrium price. And let me write the equilibrium price on the left-hand side rather than the right-hand side. So it'll just be A plus E I 0 over B plus D. Notice on the right-hand side, all we have are parameters and exogenous variables. So that's the proper form. So now we're ready to look at the comparative static derivatives. Now, what we will assume, we'll assume that the equilibrium price is positive. Okay, if we assume that the equilibrium price is positive, what does that mean about A plus EIO? What can we say if the equilibrium price is positive? Then what can we say about A plus EIO? Well, what do we know about this denominator, B plus D? Positive, because B is positive, D is positive. So in order for the equilibrium price to be positive, what must be true about A plus EIO? Positive. This is despite the fact that we know that E is negative. Okay, even though E is negative and I is positive, it must be the case that A plus EIO has to be positive in order for the equilibrium price to be positive. Okay, so for this market to exist, the price, of course, has to be positive. Can't have a negative price. Okay, so we'll assume this as well. Okay, now let's do our comparative static derivatives. Partial P star, partial A is what? Anybody? Helen? Was it you, Helen? Oh, Heather. Yes, 1 over B plus D. And we know it has what sign, Heather? Positive, because B and D are positive. So this has to be positive. So in words, that means, Heather? Exactly. P star and A move in the same direction. Okay. All right, let's do partial P star, partial I. That's another easy one. What is that going to be? Consumer income is assumed to be exogenous in this model. So what is partial P star, partial I? Andrew? What is it? Yes, the coefficient on I is just E over B plus D. And given what we've assumed about E, what is the sign of this partial derivative? Negative. Okay, because E is negative. So, Andrew, that means, that implies what? Exactly, that I and P star move in the opposite direction. Okay. Then I also ask for partial P star, partial B, didn't I? And partial P star, partial B. And actually, we know that partial P star, partial B, and partial P star, partial D are going to be the same. So you could verify this. These two will actually be the same. And what rule will we use to get partial P star, partial B? Diana? Okay. So, and what would it be if we use the quotient rule, Diana? Okay, the derivative of the numerator with respect to B is 0. Okay, times the denominator minus, yes, the derivative of the denominator with respect to B is just going to be 1 times the numerator all over the denominator squared. Okay. Okay, so this will be minus A plus EIO over B plus D squared. Or, simplifying this, we could also write this as what? Yes. If you just take this, ignore the minus sign, this over one of these is just P star. So this is just minus P star over B plus D. So the sign of these two partial derivatives are what? Negative. Okay. Meaning that B and P star move in the opposite direction. D and P star move in the opposite direction. Okay. Now, the last part of this problem was to show these effects using supply and demand diagrams. Okay. Again, to repeat, our demand function is this. Where we are assuming A positive, B positive, E negative. Okay. So, and our supply curve is where D is assumed to be positive. So, our supply and demand diagram looks like this. If we graph price on the horizontal axis and quantity on the vertical axis, how would we graph this demand curve? This is a little bit tricky. What is the vertical intercept of the demand curve? Okay, not quite A. Before, you're right, Heather, if we didn't have this term here, as we didn't before. But now in this model, we're adding this term. So if P is 0, what would the quantity demanded be? Yeah, it's A plus EI. So A plus EI is the intercept. Now we are assuming that A plus EI, as I explained earlier, is greater than 0. So it's a positive intercept. Okay. Then the slope of the demand curve is just minus B. So it's the same as before, except the intercept is now A plus EI. So the slope here is minus B. And since B is positive, the slope is negative. Okay. The supply curve, if I draw the supply curve, what does it look like if we graph it? Ben, what's that supply curve look like? Okay, because D is positive, right? What about the vertical intercept? Yeah, the origin. Comes right out of the origin. So the supply curve is just a straight line with a positive slope coming out of the origin. The slope of this is D. Okay. Where they intersect, if you drop a perpendicular from this intersection right here, this would be your P star value. Okay. And let's call this a P star value 0 for the initial situation. Okay. For the initial values of A, E, I, and D. All right, now we can do comparative static analysis using our graph. If there's an increase in A, what would that do to the demand curve if A were to go up? What happens to the demand curve in this diagram? It shifts. Yeah, okay, or it shifts vertically upward. The intercept increases. So it'll shift. And what about the slope? It's not changing because the slope is minus B. B stays the same, so the slope doesn't change, so it's a parallel shift upwards. So what happens to the equilibrium price? Goes up. The new equilibrium point is right here. Let's label the original equilibrium point A, label the new one B. So the new equilibrium price is P1 star. That's consistent with this result right here. P star and A move in the same direction. Okay. Well, you could illustrate each of the other shifts by just shifting the appropriate curve. In this case right here, if we were to illustrate I going up, what would change now? Actually, I could use this same diagram. What would happen to the vertical intercept if I goes up? Assume we're starting with this case right here. This is the original demand curve. Here's the new demand curve. Well, I going up is also going to shift the vertical intercept up. Oh, I'm sorry. I made a mistake. What is it going to do? It's going to shift it down because E is negative. Okay. E is negative. So we're going to need a new diagram for this. That one's going too fast. Okay, so here's our original diagram. A plus EI. Here's our supply curve. Here's our original equilibrium price. Now, if I goes up, since E is negative, the new demand curve is going to shift downward. But the slope will be the same because B is minus B is still the slope. So it's a parallel shift. So here's A plus E I 0 prime, where I 0 prime is greater than I 0. Okay. So now what happens to the price? It goes down, which is consistent with our finding that this partial derivative is negative. Okay. All right. Well, I'll let you do the other two. If B were to increase, what happens in the diagram if there's an increase in B? Dinah?
A change in the slope.
Yes, a change in the slope of what?
The demand curve.
Yeah. So if B goes up, the demand curve then becomes steeper. The slope becomes more negative, so it becomes steeper. And that would obviously cause the equilibrium price to fall if the demand curve becomes steeper.